Hi guys, welcome to today's tutorial. Today we'll be looking at trigonometry. So get your writing materials ready with your calculators. We'll be right back. Welcome back. Now, our basic trigonometrical ratios include our sine, cosine, and tangent. Now, these are the ratios of the acute angle in a right angle triangle. Now, before you talk about sine, cosine, and tangent, we are basically going to look at a right angle triangle. So, the acute aspect of a right angle triangle forms is what we use in determining our sine, cosine, and tangent. Now, in the right angle triangle, we know that we have the longest side of the right angle, which is our hypotenuse, all right, the opposite and the adjacent. Now, we can define our hypotenuse as the longest side of a right angle triangle, or the side facing the 90 degrees. So whichever side faces our 90 degrees of our right angle triangle is our hypotenuse. Now, when we talk about adjacent, opposite and adjacent can easily be interchanged depending on where is bearing the acute angle. Now, our adjacent is the side bearing the 90 degrees and the acute angle. Adjacent is the side bearing the 90 degrees and the acute angle, while opposite is the side facing our acute angle. Okay, opposite is the side facing our acute angle. Hypotenuse is the side facing the 90 degrees or right angle. Then adjacent is the side bearing our 90 degrees and acute angle. Now, in determining our trigonometrical ratios, we use the term SOH-CAH-TOA. SOH-CAH-TOA. Now, what does SOH-CAH-TOA mean? SOH-CAH-TOA simply means opposite. For sine theta, we are having it as opposite over adjacent over hypotenuse. For sine theta, we are having it as opposite over hypotenuse. For cos theta, we are having it as adjacent over hypotenuse. Adjacent over hypotenuse. And tan theta, we are having it as opposite over adjacent. Opposite over adjacent. Now back to our triangle. Now, for us to determine our sin theta and cos theta and tan theta, now if this is position A, B, C on the triangle, our adjacent becomes A, small a, opposite becomes small c, and hypotenuse becomes small b. So our sin theta, which is opposite over hypotenuse, will become opposite, which is c, over hypotenuse, which is b. And cos theta, which is adjacent over hypotenuse, will become adjacent, which is a, and hypotenuse, which is b. Then our tan theta will become our opposite over adjacent, which is c over a. Now we said note that tan theta is also sin theta over cos theta. What do we mean? Now, if we know that sin theta is c over b and cos theta is a over b, all right? Now, this is sin theta, c over b divided by a over b. Now, if we take the inverse of our denominator, which is cos theta, that will become c over b times b over a. Okay, so these we cancel out, leaving us with c over a, which is same thing as our original tan theta here. So we can also say that our tan theta is equivalent to sin theta over cos theta. Talking talking about ratios of complementary angles. When we talk about complementary angles, we know that complementary angles are angles that sum up to two angles that sum up to 90 degrees. Complementary angles are two angles that sum up to 90 degrees. So in a right angle triangle, if this is theta, all right, we know that in every triangle, the sum of the three angles will sum up to 180 degrees. So the sum of angles in the triangle is equal to 180 degrees. So if this is 90, that means these two will sum up to 90 degrees to make 180 degrees in this triangle. So if we have theta at those points, that means for this angle here, we are going to have it as 90 minus theta. Okay? As 90 minus theta. And we know that if this is our adjacent, opposite, and hypotenuse. Okay? Now, we have this as CAB. Okay? Now, we know that sine theta, we've established that sine theta, which is this, is equals to opposite over hypotenuse, which is C over B. Okay? Now, if we look at the complementary angle of sine theta, okay? Now, in this complementary angle, this will now become our adjacent. Okay, our C becomes our adjacent. Choosing this complementary angle of 90 minus theta, C becomes our adjacent and A becomes our opposite. And where do we have adjacent of our opposite? Remember our rule that says SOH-CAH-TOA. Okay, so our adjacent versus over hypotenuse will become our adjacent, which is C, using this angle now. Our 90 minus theta will give us adjacent, which is C, over hypotenuse, which is B. That is cos. Okay? Using this we are having cos 90 equals to 90 minus theta, okay, cos 90 minus theta equals to C over B. That is why we're having it as the complementary ratio of sine theta, okay. So the complementary ratio of sine theta will be cos 90 minus theta, okay. Likewise for cos, if you're having cos theta as A over B, now our A is adjacent, okay, and B is hypotenuse, okay. Now for using our complementary angle as this, considering our complementary angle 90 minus theta, this will become A will become opposite and B will still be our hypotenuse. So where do we have opposite and hypotenuse? Sine. So this becomes sine 90 minus theta equals opposite A over hypotenuse B. Okay, that is how we got cos theta equals A over B, which is sine 90 minus theta. So cos theta is equivalent to sine 90 minus theta because they are complementary angles. Now for tan, remember we said that tan theta equals to sine theta over cos theta. Alright, now for us to get the complement of sine and tan theta is going to be cot theta. Okay, so our cot theta, which is A over C, and in this form we know that our tan theta equals sine theta, and our tan theta is opposite over adjacent, which is C over A. So now we know that its inverse will become cot theta. So we having cot theta gives us A over C, all right, which is the inverse of tan theta. Okay, so for our tan theta now, this being our theta, which is 90 minus theta, will give us A, which is our adjacent, over opposite, which is same thing as cot theta, which is A over C. Okay, now talking about reciprocals, all right. Now our reciprocal ratios simply means the inverse of our ratio. Okay, reciprocal ratio means the inverse of our ratio. Okay, so for 1 over sine theta, 1 over sine theta is equal to cosec theta. 1 over cos theta equals to sec theta, and 1 over tan theta equals to cot theta. Remember that our tan theta, like we said, is C over A. So if we have 1 over C over A, that will give us A over C, which is same thing as our cot theta. So 1 over cot tan theta will give us our cot theta. Alright, looking at our example 1, our example 1 says find in this triangle, right angle triangle, we have 5 as our hypotenuse. Remember, as we leveled it, we said that for every side facing the 90 degrees will form our hypotenuse. So this forms our hypotenuse. Alright, this bearing 2 angles forms our adjacent, and opposite this forms our opposite. Alright, now we are considering theta as our angles. You can see we have 2 angles. We know that alpha is complement to theta. Alright, since both of them will give us 90 degrees. Now, but considering theta, okay, this will be our adjacent, hypotenuse, and opposite. Alright, now our first question says find sine theta. And we know that from our SOH-CAH-TOA, sine theta equals opposite over hypotenuse. Now, what's our opposite? Our opposite we do not know. Okay, so we are going to find our opposite using Pythagoras theorem. Now, Pythagoras theorem says that in a right angle triangle, that the square of the hypotenuse is equal to the sum of the square of the opposite and adjacent square. Alright, so that means using our Pythagoras, it says that hypotenuse squared equals opposite squared plus adjacent squared. Now, our hypotenuse in this case is 5, so this will be 5 squared equals opposite we do not know, let's call it x, plus adjacent, which is 3 squared. So 5 squared will give us 25 equals x plus 3 squared will give us 9. So collecting like terms, x equals 25 minus 9, which will give us 16. So our x squared, x will give us root of 16, which will give us 4. Okay, now knowing that our x is 4, which will not be our opposite, so opposite is 4 cm. Now we can now answer this question comfortably well. So our opposite is 4 and hypotenuse is 5, so this becomes 4 over 5. Alright, now to the next question that says find cos theta. Now our cos theta says is adjacent over hypotenuse. Now adjacent is 3 and hypotenuse is 5. Okay, next one says cos alpha. Okay, so now if you are looking at cos alpha, that means we are considering this angle. So here will become our adjacent, considering alpha, and here will become our opposite. All right, so considering alpha, adjacent over hypotenuse will give us adjacent is 4, our hypotenuse is still 5. Now the next one says tan theta. So considering theta, here will be our adjacent and here will be our opposite. Okay, now tan theta will give us opposite over adjacent, which is opposite is 4, adjacent is 3. Now the next one we have is sec theta. Now sec theta is 1 over what? Our cos theta. Sec theta is 1 over cos theta. So what is cos theta? Cos theta we found before to be 3 over 5. So if we turn it around, this will be 1 over 1 times 5 over 3, which will give us 5 over 3. So this is our sec theta. Now the next one is cot f, cot theta. Now cot theta we know is 1 over tan theta. Okay, and 1 over tan theta we found out to be 4 over 3 will give us 1 over 1 times 3 over 4, which will find out answer will be 3 over 4 will be cot theta. If you've enjoyed our lecture so far, don't forget to subscribe, like, and click on your notification button for more updates. Follow us also on Facebook at Mathematics Simplified. Given that theta is an acute angle, find the value of theta if A. Sine 70 equals cos theta, B. Cos theta equals sine theta, C. Sine 2 theta equals cos 70, and D. Cos theta equals sine theta plus 54. Now, in solving this, we know that for sine theta, okay, our solution 1A, we know that sine 70 equals cos theta is a question. Now, if we look at the complementary angle of sine theta, all right, from what we learned earlier, this is sine theta equals cos 90 minus theta. All right, that acts as our complementary angle. So now, where theta is equal to 70, okay, our theta here is equal to what? 70. So that means sine 70 equals cos 90 minus 70. So this will give us sine 70 is equivalent to cos 20 degrees. So our sine complement of sine 70 will be cos 20 degrees. All right, now looking at the B part, so here our theta for here, our theta here will be equal to 20 degrees. All right, looking at the B part, we have it as cos theta equals to sine 90, same thing, B, okay, cos theta equals to sine 90 minus theta, okay, since both are equal. So this can now give us sine theta equals to sine 90 minus theta, okay. Bringing them together will give us sine theta, opening this bracket to give us sine theta equals to sine 90 minus sine theta. So this goes over to give us sine theta plus sine theta equals to sine 90. Okay, this will give us sine 2 theta equals sine 90. This cancels this, leaving us with 2 theta equals 90. Okay, so theta equals 90 over 2, which will give us 45 degrees. So our theta in this part, in this B part, will be 45 degrees. Sine 2 theta equals cos 70. Now, bearing in mind that our sine theta is cos 90 minus theta. Okay? Sine 2 theta is centering as having as cos 90 minus 2 theta. Okay? But we know that our equivalent of sine 2 theta is cos 7 theta. Okay? So now replacing 2 theta with cos 7 theta, this will give us cos 7 theta equals cos 90 minus 2 theta. Now, bringing our terms together, this will cancel this, leaving us with 7 theta equals 90 minus 2 theta. So going over will become 7 theta plus 2 theta equals 90. So therefore 9 theta equals 90. Theta equals 90 over 9. Theta equals 10 degrees. So our theta for this will give us 10 degrees. Now, looking at the top part, okay, this is C. Looking at D, our D part says cos theta equals sine theta plus 54. Alright, and we know that cos theta equals sine 90 minus theta. Okay, now for this is the complement of this. So next thing we are going to look at is how to equate these two. So since cos theta equals to this and sine this, so we can now say sine 90 minus theta equals sine theta plus 54. Okay, so this will cancel this, leaving us with 90 minus theta equals theta plus 54. Okay, so if we collect like terms, this becomes 2 theta equals 90 minus 54. And we know that 2 theta equals 10 minus 4, 6, 8 minus 5, 3. So our theta will now become 36 over 2, which will give us 18 degrees. So our theta will become 18 degrees. Alright guys, with this, we've come to the end of today's tutorial. If you have any questions or comments, put them down in the comment section below. Don't forget to subscribe, like, and click on the notification button. for more updates. Follow us also on Facebook, on our Facebook page at Mathematics Simplified. Thanks.